processing at nano resolution allows for seeing industrial applications by looking into material adhesion, where one can look into how we can control nanotechnology and be able to observe nano dimensions, which permits looking toward nanophysics, nanotribology, something that is exactly a part of the Excellence Group and is the end that we seek, to be able to characterize materials. Discharge chambers have been designed for thin film production. Some equipment was designed to measure magnetic properties, such as a vibrating sample magnetometer. And we have divided our work into 3 parts. One part corresponds to studies and alloys of hard magnetic materials. Another system we have been studying has been magnetic materials with magneto-optical properties for the production of thin films and mineral studies. Gold has been chosen for auriferous studies in Tolima and Colombia in general. The Novel Materials Physics Group from the Physics Program of Universidad Nacional focuses its efforts in the development of novel materials with superconducting magnetic and ferroelectric properties. We eventually developed new ceramic materials that serve or could serve as sensors for toxic gases such as carbon monoxide. We also designed these materials by studying their properties from the theoretical point of view through the DFT technique. This helps us know if the materials we're going to fabricate are going to have the expected properties, or to the contrary, we corroborate through theoretical models the experimental results obtained from the electronic mechanisms of ceramic types from the peructite family. The Excellence Center for Novel Materials CENM is part of a national effort of high scientific priority. Nearly 80 PhD researchers are involved. Another effort is that of incorporating, supporting, and training young researchers from different universities around the nation so that they participate as highly qualified scientists in the work of the Excellence Centers. The Excellence Center for Novel Materials, CENM. Our goal is to reach scientific excellence and technology transfer for the benefit of our nation.
Okay, so I hope you have a good idea of the groups who are involved in the center, and let me continue with the presentation. The area that are involved in this center are composite material, advanced coating material, nanomagnetism, solid-state devices, sensor and mesoscopic system. By the way, here is the logo of the CENM. This is nanolithography done at our AFM system we had acquired. I will show you. And here some nano particle, magnetic particle by using this microscope. Let me show you very quickly the text in this area. In the nanocomposite material, the more important topic is active nanopowder for cementitious basis material from industrial waste and industrial byproduct to produce cementing material with high mechanical performance, durability for civil engineering infrastructure in our country. In the hard coating material, as you saw here, we are working with composite coating, silicon carbide and nickels, chromium and nickel phosphide with a nano-size iron oxide particle to improve this coating. And one of our main topics is multi-layer coating, tungsten carbide, tungsten, the titanium nitride, titanium silicon, and our work on titanium carbide nitride and titanium carbide nitride with niobium multi-layer. This will be the topic of the talk of tomorrow, more specific in this multi-layer. This is the system we have. This is a pilot plant for producing this type of multi-layer. And here is some example of we can do with this type of multi-layer titanium nitride, carbon nitride, boron carbon nitride, on boron nitride multi-layer. In the case of nanomagnetism, we are working with oxide-based magnetic thin film and heterostructure, special manganite. Here are some examples of the magnetic property of manganite, lanthan cobaltite on lanthan manganite thin film. We have also theoretical numerical simulation of nanomagnetic behavior and nanocomposite and nanostructure magnetic alloy for hard and soft magnetic material. In the case of solid-state devices, we are working especially with optical and electric and magnetic property of quaternary semiconductor, ionic material, photonic material, and also I will show you at the end some report on vanadium oxide thin film. This is a recent work of one of our students on this type of oxide. Here is a summary of the production of the center in the last 5 years. More than 183 international papers, also in national journal, from all of the area of the center. Here is in some summary. We have more than 300 publications. We have participated in a lot of conferences around the world. We have agreement with the company, with 6 companies, agreement with state entities, and agreement with educational entities, and in order to transfer our result to the society or to the industry. One important thing in this center is formation of high-level students, PhD students. We have in the 5 years around 14 PhD who did his thesis in the center, 16 magister, and graduate student involved in same project around 46, and joint research 6. It's a lot of people, young people who are involved in this thing. We have supported different events. One is the Trends on Novel Material in year 06, supported by our national, for the National Science Foundation, and the Iberomed. This was a big conference in Cartagena in 2008, and this meeting in Cali, Non-Conventional Material and Technological NOCMAT, with the support of Brazilian institution. This was a seminar on ferroelectric and the electric material with the support of the National Science Foundation and the University of Florida, a workshop on cutting tools, and this year course on electron microscopy, not only electron microscopy, but AFM microscopy. Another task, very important task in our center, is try to bring the nanotechnology in our country. So we have different events on nanotechnology in our had different events, nanoscience, last year, nanotechnology, the revolution of this century in Bogota, also in Medellin. And this month, we will have this event, Nanoscience 2010, in Barranquilla, with the participation of research from USA, Argentina, Brazil, and also from two research from this center, Professor Rahman and Aline, and this will be a seminar on broad scope on nanoscience, and the main idea of this seminar is try to put in contact group in Colombia and group abroad, our country, working in this area. To do research, all of you know, need equipment, not only people. And one of our main goals for them is try to acquire state-of-the-art equipment to do research in novel material. Without very good equipment, state-of-the-art is impossible to do this type of research. This is our PPMS from Quantum Design. This is a firma in San Diego. State-of-the-art. This is a multi-purpose system. You have the possibility with this system to do electric, magnetic, and thermal measurement under very controlled environment, magnetic field, and temperature. This is top-of-the-art equipment for this purpose. The cost of this equipment is $500,000, and this is quite good system.